For anyone who knows Dr. Lee, see if you can see the ponytail. I'm Dr. Lee today. Like Dr. Lee, like 10 years ago, before the ponytail was majestic. That's me. And we got a penguin. And I've already been throwing candy around pre-class, so like this is gonna be a good day. All right, let's share a screen for you guys. So the last thing we were talking about, kind of some people that were in the room saw it, was right. So we ended that synthesis last time, and I was like, oh yeah, it's a cis double bond. And I was like, I'll show you how you know it's a cis double bond next time. It's next time. Right, so when Br2 adds to a double bond, the bromines end up on opposite sides, right? One ends up forward, one ends up back. So let's say we have wedge and dash. Super easy, right? When you have a cis double bond, you have Br2, still one bromine ends up forward, one bromine ends up back. But we normally don't draw our carbon chains like this, right? Where the two carbons or two carbons of the carbon chain eclipse each other. But we usually draw them in kind of what amounts to like the anti-staggered conformation where the carbons are on opposite sides, right? So if you rotate around this bond, right? Again, curly Q arrow. If we just rotate around that bond, one bromine, this bromine will stay the same, right? But the other bromine will end up being forward. So if you see it where your two bromines are on the same side, or your halogen and your OH from a halohydrogen synthesis are on the same side, that is more than likely because you had a cis double bond, they were on opposite sides, and then the single bond got rotated to make it look like they were on the same side. So if you see them on the same side, think, oh, I needed a cis double bond. If they're on opposite sides like they normally are, then if they're on the same side, then it was a cis double bond. Opposite side, it's a trans double bond. So that's the little trick to kind of clue you in. I have an answer.
So I was asked if there were any negative interactions or consequences to having the two bromines both be forward or both be back.
No, they may not. Right. So if you were to draw it out, kind of like in a sawhorse conformation. So it was like the question was, do they care if they're on the same side? Right. And the answer is kind of no. They're not thrilled. This isn't probably the lowest energy conformation, but they can exist in that conformation. They're not like eclipsing each other. They're pointing out, but one's kind of angled up and one's kind of angled down. So there is space. They're gauche, right? But to get them on opposite sides, you kind of have to put the two methyl groups eclipsed or close to it. So you can't like avoid the gauche interaction. But we normally just draw the molecules this way, just kind of for like neatness' sake. And so we just end up drawing them that way. So we're not taking into account like what the low energy conformation is. No, there's no like weird interactions. They're not like eclipsed or anything like that.
I was asked about what set of reagents you pick if there are two sets of reagents that do the same thing.
Oh, yeah. So like, go ahead. So I had something like this, and then I was like, hey, make a ketone. Mm-hmm. Yep, pick one. So the key for me, like on the exam, is to make sure that like you only have one option, right? But if you have two reactions that do the same thing, for the most part, for us, it's not gonna matter which one you pick, right? If this was a real semester, right, we weren't all wearing masks, right? I could give you, this question mark ketone, and if half of you picked hydration and half of you picked hydroboration, you'd all be right, because both those reactions do the same thing, right? But this semester, where it's going to be some sort of matching or multiple choice thing, or you're going to be dragging things into boxes or whatever, right? You're going to have to make sure that you know both of them, so that if you only see the hydroboration, you go like, oh yeah, that makes a ketone from an internal alkyne. I can use that to make this ketone. So the first three are something that I end up kind of going back to a lot. What you have to ask yourself is, how do you know how to make alkynes, right? And I've kind of given you two ways to make alkynes. So what are the two ways you know how to make alkynes? You can use two equivalents of KOH, and what do you need with the KOH? Like, what does the KOH have to react with? Well, what is the starting material? So it's something plus KOH makes an alkyne. Well, not heat, the thing before it. Halogens. It's specifically a vicinal dibromide, right? Two bromines on adjacent carbons. So you can do this with either, right? You have two bromines and then two equivalents of KOH and heat, and that makes an alkyne. That's a really bad heat, but you know what I was going for, right? Or you had like a vinyl halide and then NaNH2, then water, and that'll make an alkyne. All right? So those are the two ways you know how to make an alkyne. Which of those starting materials, the dibromide or the vinyl halide, can you make from an alkene in a single step? The dibromide, right? So the way that you can turn an alkene into an alkyne is you turn it into a dibromide, and then you treat it with two equivalents of KOH and heat, and that'll turn into an alkyne. So that is going to be kind of one of your like little shortcuts, if you will, is, hey, if I have an alkene and I have to turn into an alkyne, the best way or the easiest way for you to do this is to brominate it and then treat it with two equivalents of KOH. That's going to get you from that alkene to the alkyne. So now what do I have to do down here, D, E, and F? Good job, Happy Feet. That was bad. That's on me. College athlete, nerd. Hey, I've been to a baseball and a softball game. After every pitch, they throw the ball back to you, and you have to catch it. All right. So we have to add carbons, right? This has 4 carbons. This has 6 carbons, right? So I need to add 2 carbons. So this is kind of our, what base? N-butyllithium. And then I need to add 2 carbons and a halide. This is what we ended on last time. How do we make that cis double bond? H2 and large catalyst. If I keep throwing candy at you, you might go into like some sort of weird sugar coma. My college athlete tried to throw trash in the trash can and like basically hit the bottom of the trash can from like 6 feet. Like not even close to the top. Didn't like hit. It's like bottom. So far so good. Back to chemistry. Gonna focus back up here. Okay, so we had this on the last slide. Right now I want to make that. You can pitch into Zoom, but I can, like I said, I can only throw candy at the screen. It's not like nearly as good. See, because I'm an artist, I made sure that the candy bar got into the frame of the camera. Because I'm an artist. This is a performative piece. So how do we add OH and chlorine to a double bond at the same time? Halohydration, right? So I need chlorine because that's the halide I'm adding, and I need to add water. Now this is the opposite trick as with like halogenation and halohydrin synthesis, right? Usually we put alcohols on from the same side, right? So then when we twist around our double bond, they look like they're on opposite sides. So what is one of the two reagents you can do to put alcohols on to a double bond to make a bisphenol diol? So we know two reactions that will remove a double bond and put an alcohol on each carbon of the double bond. Name one of those two reactions. Oxymercuration adds one oxygen. Hydration adds one oxygen. It was from, I'll tell you the name of it. It's a dihydroxylation. Di for two, hydroxyl for alcohols, lation for put on, I guess. I don't know. Right? So, how do you do a dihydroxylation? Also, fun fact, your next test is in 2 weeks. And your finals in 3 weeks. Yes, permanganate. What kind of permanganate? Well, potassium permanganate, yes. There are two words described for that potassium permanganate. Cold and dilute KMnO4. So, cold dilute KMnO4. Yes! Hit it right in the arm. So this is my friendly reminder. You're not allowed to forget anything ever. Because in organic 2, I'm going to sneak one of these in, and you're going to be like, son of a... It's not nice. It's organic. I don't get paid to be nice. I barely get paid now. So where do we want to start? Do we want to start with A, B, and C? D, E, and F? Start with C. BR2. Good job. Or what's that functional group called? What is B? You said the hydrocarbon chain without the alcohol on it, but that has a name. It's got the carbon. It's got 2 bonds to another carbon. Gives with an A. Alkene. And then so you know where the double bond is because of where the bromines are, right? The bromines end up on either side of the carbon or either side of the double bond. So wherever those bromines are, that's telling you where the double bond was in B. Now, how do I get from alcohol to double bond? Sulfuric acid and heat will do the job. What if I'm on a lot of sulfuric acid? Yeah, phosphoric acid and heat, H3PO4 and heat, or H2SO4, either one. The penguin is very, very Katie motivated. All right, so now D, E, and F. Yep. Two equivalents KOH and heat to make an alkyne. How do I do this? What is this one? How do I get from E to the ketone? We just did this. Never forget. OH, correct? Yes, there's something else. H2SO4. Hmm? Hydroboration is the other one. So far, so good. The super review of everything you ever learned. You know D. What is D? We're all out. What's the other thing you have to use? We're all out of cold dilute KMNO4. We only have warm. We only have warm stuff. No ice. Now what? Because again, like you are, right? In a normal semester, you could just latch on to cold dilute KMNO4 and just be like, if I ever see this, I'm gonna do this. But if I give you the other one on the exam and you don't know what it does, then like that's no bueno. So it's the other way other than cold dilute KMNO4 that we can do this. You were doing hangman OSO4 H2O2. Osmium tetroxide is OSO4. Osmium tetroxide. It's in the video with the hydroboration mechanism. Like you may have just like given up. Well, I've got to. So for A, I've got to turn. I've got to. B has to be something I can turn into a double bond again. So how do I? How can I turn the alkene into something that I can turn back into an alkene? Hmm. But my alkene has to move, right? It has to go from being the least substituted alkene to the more substituted alkene. But what do I have to turn? You do remove it and add it back, but what do I turn it into? Like if I just use like H2 palladium on carbon and just make butane, you don't know how to go from butane to a double bond. That you have to have some functional group there that you can turn into a double bond. So the question is, what ways do you know how to make double bonds? All right, left that one wide. Try again. Okay, that was okay. First one was old Tom Brady. It was like old man Tom Brady, like hit the door, didn't hit the student. Second one was like young Tom Brady, like right on the numbers. What are ways you know how to make double bonds? Okay, let's answer that question first. How do we know how to make double bonds? Sulfuric acid and heat, and what do I need to have for sulfuric acid and heat to work? I need to have an alcohol. Okay, so I can turn an alcohol into a double bond. So how can I turn how can I turn the alkene, 1-butene, into an alcohol? Hydration. So you could say like, hey, water, sulfuric acid is going to make this alcohol. And if I use sulfuric acid and heat, I can eliminate that and make that double bond. What if you're all out of sulfuric acid? Hey, I just got to make sure you know everything, not just one thing. What is another way you know how to make double bonds? Lindlar's catalyst is alkyne to alkene. And you're right, we can do that, but we don't have enough steps to like turn this into an alkyne and then turn into an alkene. Hmm? Yeah, well, not a different reaction for C, like A, B, and C. There's a totally different way you can do these 3 steps, right? What if, excuse me? Okay, so if you use like sodium hydroxide or sodium methoxide or something, a metal with your base, right? What does it have to react with to make a double bond? What is the starting material for those reactions? It's something plus base equals double bond. What is the something? A halogen. So what if we had, instead of water, what if we had, or so instead of an OH, what if we had a halogen here, a bromine or a chlorine? Right, then we could use a base, and that would make our double bond. How would I turn my alkene into that halogen? So this is the long throw. This is where it can go bad. Here we go again. Okay, that's pretty accurate. That's right. So again, sometimes there are multiple ways to do things. And so again, let's say like on the exam, let's say I had this as a reagent, but then I didn't have the alcohol as the product, right? But I had the HBr, the 2-bromobutane, and the sodium hydroxide. I'd be like, oh, I have to pick this way because all of those reagents and products are present as options. Where if you're like, well, I could turn it into an alcohol, but then the alcohol product's not there, and then like the sulfuric acid for the elimination isn't there. So you're going to be limited on what reagents you have present to actually do stuff. You should 100% know what F is because this was the 3rd time I've done it. Lindlar's catalyst in H2. Right? So that means that where the cis double bond was, there was an alkyne. Oops. And it's only like the 400th time that we've done D. Mm-hmm. C is Br2. Right? So that means where the 2 bromines were had to be a double bond. So then that gives you so how can we go from the double bond that I gave you to the double bond that you got? Olefin metathesis. Yeah. Yeah, so we need to add 1, 2, 3, 4 carbons. So, well, 3, and then you need the double bond. So it's really ugly. Let me try again. I'll draw it this way. Right, and then what do I have to add with my 2 double bonds to put them to groups 2? Great, so you're going to have this double bond is right, or this carbon's right here. Then you have this one right here. That's a G, I swear. That was a long ago complaint on one of my teaching evaluations. His 6's and his G's look too much alike. I was like, hey now. So how can I go from that to the, so from that alkene to that bromide? Now you'll get a mixture if you doing this reaction conditions, but this is one of the products. So if I give you a step that you're gonna get a mixture, as long as the conditions you use give me one of those products, I'm good. HBr, right? So, yep. So if this, so if you remember, right? So if I have HBr, right? Some part of the time, my hydrogen is going to add to the far carbon. And make a secondary carbocation, right? And then your hydrogen will shift over and make a tertiary carbocation. And then your Br minus that you generated can add to that carbon, and that will give you your product. Is it now? Admittedly, right? Some part of the time, the hydrogen is gonna make the other carbon. You're gonna make the other carbocation. You're gonna get a different product. But as long as you're getting one of the two products I asked you for in your method, that's fine. What to do you know? The bad thing was my bag of candy started out full at the beginning of the week, and like just at my desk, I was like, just slowly. I was like, I gotta try to save some to throw at people. It's the only time like I can like it's socially acceptable for me to throw stuff at you guys. This is something that throws people because I will let you just use like a big piece, right? So you're adding this many carbons to your little acetylene, right? So this is 1, 2, 3, 4, 5 carbons. So we're gonna have our halide, whatever it is. 1, 2, 3, 4, 5, right? 3, 4, 5. 1, 2, 3, 4, 5. We're good. And then that's step 2. And then step 1 would be a base. Pick a base. Well, you see, I know the answer, but I want to see if you do. LDA work. I want to just draw it the same way as the product. How can I turn my alkyne into an alkene? Wait, I might have too many carbons in my ring. Oops. It's a little house. Sorry. NaNH3 will get the job done. Feel bad. I feel like we're gonna get a call from your coach. It's like she's too cracked out. You can't do this ever again. All right. So how can I go from this straight chain molecule to a ring? I hope Zoom's playing along. I hope they're like sitting around and thinking and flipping through their notes and being like, "Oh my God, this is my life now." All of the metathesis again. Pick a catalyst. Grabs one. Yeah, I hit the chair in front of him. That's late stage. That's late stage Peyton Manning when his arm strength wasn't there and it just they all came up short. That was that one. Right. So that'll make a 5-membered ring. See, we're not adding anything, right? I have a double bond on each side. I have two double bonds in the molecule, so I can go this carbon will end up bonded to this carbon. So like here to here, and if I count, I have 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. Yep. I'm not going to throw another one. You have to get that one to hit share 9. Right? So I think that was like a reasonable review of a bunch of the reactions that you know. And if you look at the old tests, there's usually a problem that is usually 12 to like 18 points that is just something like this where I've lettered out a bunch of steps, and then you have to fill in a combination of the correct reagents and products. What I did in Organic 2 when it was on Moodle was they were matching. Again, I have to find the right balance of number of possible reactions, number of things you have to match, just so you don't have like a giant list. I think the first one I did for Organic 2, I think it had like something close to like 30 possible options. It was too much for them to go through. It broke them. So we've tightened it up. But you're gonna have something like this where it's gonna be matching, or again, if I can figure out how to like draw or drag pictures onto things to put things in the right order. Just something where you have to go through and like build a synthesis. So make sure the key to them is knowing your reactions, right? Because I think it's easiest is to like sometimes look at a product and think, how do I know how to make that? What 3 or 4 reactions do I know that let me make that compound? And then say like, well, I know that I need, right? So kind of like we did with the alcohol. Go back. Right? It's like, well, I know I can make an alkene from an alcohol. Can I get from the alkene I'm given to an alcohol that makes this double bond? And you're like, oh yeah, I can do that. So that's a reasonable pathway. Same thing with the halide, right? But sometimes the things that you need as your starting materials, you can't make from the things you're given. So kind of like if you've made an alkyne and you're like, well, I know that I can make alkynes from 1, 2, 3, 4 from a vinyl halide, or I can make them from a dibromide, right? If your starting material is this alkene, right? You don't know how to go from an alkene to a vinyl halide, right? So even though this is a possibility, you can get from here to here. You don't know how to get from. You don't know how to do that, right? You don't know how to get from there to there. So you can eliminate the vinyl halide as an option for a thing that you're going to use to make that alkyne in this case, because you don't know how to get from alkene to vinyl halide, but you know how to get from dibromide to alkyne, and you know how to get from alkene to dibromide. So you can say like, oh, I know how to do that. That'll be the path I take, right? So sometimes you're just limited by, like, I have multiple options, but what I can make from my starting material tells you what you have, tells you what you need to do. And so with that, stay inside. Don't get the Rona by trying to get candy, or like whatever college kids get, alcohol and bad decisions. So stay safe. I will see you guys Monday. Forgot to start recording. It's gonna just start right there to scare some people on YouTube. It's the first time I've forgot to start recording. Good job, man. Distracted by cute baby. That's what it was. What we're going to do today is like part review of like most of the reactions we've gone over, and part just helping you kind of like look at things and think about how things go together and what things you need to look at to know, to like figure out what your products are, what your starting materials are, and things like that. So we're thinking about A, B, and C. We're turning an alkene into an alkyne. And so the first question is, how do you know how to make an alkyne? You know two ways to make an alkyne. Not dehydration. That makes alkenes. Dehydrohalogenation of what? The dehydrohalogenation is just a broad term for removing a hydrogen and a halogen. So if I want to make an alkyne, I could take a vinyl halide of some sort and add NaNH2, then water, right? And that would make a terminal alkyne. So that's one way. What's the other way? It involves heat. Make an alkyne. No. KOH. CD 2 equivalents of KOH. Oh, here. This is not as fun for Zoom, but here we go, because I'm an artist. There you go. Make sure I got the candy bar in the frame. Yeah. So I don't know, throw some cereal in your mouth or something. Like throw it up in the air, catch it, be great. You need to have a vicinal dibromide, right? Do you know how to turn an alkene into a vinyl halide? The answer is no, you don't. But do you know how to turn an alkene into a vicinal dibromide? Right? So, since we know how to turn an alkene into a vicinal dibromide, more than likely our compound B is going to be the dibromide. It's a really bad BR. Right? Because we can both get from that dibromide to the alkyne and get from the starting alkene to the bromide. Right? So this would make C 2 equivalents of KOH and heat. And then how would I go from the alkene to the vicinal dibromide? How would I make B? BR2. Right? So because you could think through like the ways you know how to make an alkyne, they got you to two possibilities, right? That you needed a vinyl halide and then this base, or the vicinal dibromide and then 2 equivalents of KOH. And then you could eliminate the vinyl halide as an option because you don't know how to turn an alkene into a vinyl halide. And that just leaves you one option, and that kind of fills in A, B, and C. So, how do you know how to put two alcohols on a molecule? You're not allowed to forget anything ever. Ever. Never forget. That puts on one alcohol. That's also the undergraduate answer for everything, is to just pour some acid on it and see what happens. It was in the video with the hydroboration mechanism. So your mind might have just turned to mush as you watched that and just forgot this. And you turn it back into an alkene. Correct. What kind of alkene? A cis alkene or a trans alkene? Cis, for two reasons. One, it'd be kind of a douche move if I started with the trans alkene, turned it into an alkyne, and then to make it the trans alkene again. Kind of seems not cool. And two, the way we put on our, the way we do our dihydroxylations, right? Di for 2, hydroxyl for OHs, elation to put on, I don't know, right? Is they come on from the same side. So just like with the Br2, right, where if you have the trans double bond and we draw it out, they're on opposite sides. And if you have a cis, they look like they're on the same side. When you have a cis double bond and you do a dihydroxylation, they end up looking like they're on opposite sides. Or they end up on opposite sides when you rotate the bond. So how can I turn my alkyne into a cis alkene? That is F. What kind of KMNO4? There are 2 words that have to describe that KMNO4. Dilute's one of them, and cold. So cold, dilute, KMNO4. If that didn't work, I was gonna like start singing the song from Bring It On. Yeah. So how do I go from? So we got that figured out. So how do we get from alkyne to cis alkene? We did this at the end of class on Wednesday. Yes. Lindlar's catalyst. And H2. It's another crackle. Is that okay? I'm afraid of throwing overhand because I'm afraid I'm going to clip the projector. Like that would just be awkward. Okay. So this right here, this taking an A, B, and C, this taking an alkene, making it a dibromide, and then treating it with 2 equivalents of KOH and heat to make it an alkyne. That is kind of my go-to for how to make you go from an alkene to an alkyne. If you start with an alkene and you end up with an alkyne, you're going to be doing this, right? Oh, Lindlar's catalyst, sorry. Lindlar's catalyst. Okay. Sometimes you need to like look at these and kind of like take the easy spots, right? So, right, if you look at A, B, and C and you're like, I don't know right now, right? Move on to D, E, and F, right? So D, E, and F is something we just did, right? This is just something we should have down there, like double bond, brominate it, use 2 equivalents of KOH and heat. Br2, brominate it, use 2 equivalents of KOH and heat. K. Oh, there we go. Now, how can we get from a terminal alkene to an internal alkene? There are 2 ways that you can do this. So let's think about how do you know how to make an alkene? Sulfuric acid and heat, right? But what does that have to react with? That's how you put an alcohol on a double bond. But if you use sulfuric acid and heat to make a double bond, what did you have to start with? It's a dehydration, an alcohol. So if you're going to use sulfuric acid and heat, that means you had to have an alcohol, right? And Zaitsev's rule says you're going to make the most substituted double bond that you can, so you're going to get the double bond that is shown here. How can I turn that alkene into an alcohol? Yep. Now, what if you were all out of sulfuric acid? How could you do this where you didn't need to use sulfuric acid? What's the other way you know how to turn an alkene, how to make an alkene? What's the other way you know how to make an alkene? It does have sodium. It is a little salty. It does have some sodium in it. So we're getting there. So what's the other way to go from here to here? It involves my favorite element from last time, or it can. Bromine. There you go. It's like, well, you forgot already, right? So you have, you can put a halide on your alkene and give yourself, right? So you can have, you said alkyl bromide, and then you can treat it with a base and do a dehydrohalogenation, like NaOH, to make your double bond. And then how do I put that bromine onto that molecule? How do I make B? HBr, right? So depending on what reagents I give you, right? Because again, if this is a normal semester, I just give you A, B, and C. You have to like do it. And if half of you with water, sulfuric acid, make the alcohol, add sulfuric acid, and the other half added HBr, made the bromide, and used NaOH, you would all be right? Because they both get to the same spot. But since this is going to be like some sort of like matching fill in the blank kind of garbage, right? I've got to make sure that if I give you, let's say I give you all the reagents to do this, right? So I give you all of this somewhere, but I only give you water and sulfuric acid, right? You have to be like, oh, I don't have all the pieces. I don't have the alcohol and I don't just have sulfuric acid to turn that alcohol into a double bond. I can't use the water and sulfuric acid way because he only gave me all the pieces to do the halogenate it and then treat it with base method, right? So you need to make sure that like the things when there are multiple reagents that can do the same thing, that you familiarize yourself with both. So if I don't put your favorite on the exam, you still know what the other one does, right? If you're like, I love cold dilute KMNO4, I'm not going to learn the other one, and I put the other one on the exam, then you're like, oh no, what does this do? Right? So make sure you familiarize yourself with everything. So what you want to do first? If it were me, I feel like I'd want to do D, because it's just like one blank, right? So what would D be? I feel like this class is going to edit down to like 35 minutes. Mercury, like using like doing an oxyrecuration, like mercury, acetate, water, and THF, and then sodium borohydride, NaBH4. That only puts one alcohol on your molecule. Again, we're doing a dihydroxylation. We literally just did one version of it, like literally 5 minutes ago. Cold dilute came in a 4. But what if we're all out? What is the other way to do it? Yes, I didn't even get to finish my little hangman board. That's fine. No, osmium tetroxide and what? H2O2. Right? So if you only knew cold dilute KMNO4 and then I threw osmium tetroxide, hydrogen peroxide on the exam, right? You'd be like, oh no, I don't know what this is a new one, right? So now I have an alkyne. I have a thing with more carbons that has a trans double bond. Where do trans double bonds come from? It's a long one. Oh, that's right. I hit her in the hands. Not my fault. Not my fault. I hit her in the hands. Hey, I'm blameless here. Yeah, at the end of the first class, someone just went around and picked up all the candy bars. She was like, "This is great." Like 3 candy bars on her way out the door. She's like, "Do you want the ones that I dropped?" I was like, "No, I'm not gonna throw you candy and then be like, give it back." All right. So where do trans double bonds come from? You have a molecule that has an alkyne in it to start with, and then you have a molecule that has a trans double bond in it. So you should be thinking, okay, I had an alkyne, and it's kind of in the same place as the alkene, right? If you count 1, 2, 3, 4, 1, 2, 3, 4. So you could probably guess that alkene was at some point in its life an alkyne. So how can you turn an alkyne into a trans double bond? No, no, not dehydration. Is ringing a bell? What? What happened? Close. NaNH. One more than 2. 3. Right. So NaNH2 is a base. NaNH3 reduces alkynes to trans double bonds. So that means where the trans double bond was or is, right, there was an alkyne there. So you can say, hey, since I know that trans double bonds come from alkynes, right? I had an alkyne. It looks like I probably had the alkyne in there at some point. So you know that where the alkene was, there must have been an alkyne. So how do I get from the alkyne that I have initially, the one with 4 carbons, to B? I feel like I'm staring everyone down in class, and I got this like big poof of hair sticking out. It's pretty rough. But now look at Zoom. Zoom, you know the answers. Dear God, there's only 11 people on Zoom today. What the hell's going on? Thank you, Zoom, for putting up with me. Apparently, you should tell your Zoom friends that they should come too. LDA, you're close with the isopropyl, right? You've got 1, 2, 3, 4 total carbons. So you're like 1 carbon off. If it was isopropyl, you'd be short the carbon that I have marked 3. So you need to have 1, 2, isobromine or something. EG, yeah. I went West Virginia. I learned good. Sorry. It does. F does have water in it. And what else? Sulfuric acid. Now I'm just pointing at the person who keeps saying sulfuric acid when it's their time to shine. It is. Oh, that was oh good. Oh man. I threw that one way short. They stretched it over the desk. They really saved me there. All right. So what did that water and sulfuric acid have to react with? An alkyne. You will notice we're kind of recycling some stuff here. That's because you guys know like 15 reactions. I can only do so much, right? Right. Again, 2 bromides to make an alkyne is 2 equivalents of KOH in heat, right? So even if you're seeing kind of like different structures along the way, you should be able to like piece together like what's going on. Make our alkene, BR2, sulfuric acid. Oh, wait. Okay, bad news. We're out of sulfuric acid. What's the other acid we can use to do this? We're all out of sulfuric acid. There's another one that does the same thing. I only came with sulfuric acid. That was the only. That's the. What was that? No. Okay. Not HBr. There's an H. There's another letter that is not S. And there's a number beside the hydrogen that is not 2. And there's still heat. It's one I specifically gave you. I specifically gave you this strong acid. PO4, we did it.
So I was asked why you can't just use any strong acid, why it has to be specifically sulfuric acid or phosphoric acid.
Because, so the way it works, right, is it makes a carbocation. So if you use like HBr or HCl, the counter ion, the Br minus and the Cl minus, those are actually nucleophilic, so they can add to the carbocation that you generate. But phosphate and sulfate aren't nucleophilic. So when you make a carbocation, they don't make a bond. Right? So you've got to pick an acid that can protonate the OH to make it water to leave, but then doesn't want to add to the resulting carbocation. So where do you want to start? So you've only ever seen one way to make a ring before. Grubs. There you go. You came with acid and grubs. All right. Which one gets grubs? There's a little opening. Oh, that's really again. Oh. I almost hit. She missed the first one. I was a little high. Then I almost hit her with the second one when she was turned around. Oh, why are you blinded one eye? Well, you see, I got hit in the eye with a candy bar by my organic professor. Oh, oh. So you got free tuition? Yeah. It's like, oh, sweet. So which one is grubs? F's not grubs. D. D would be grubs. It has 2 double bonds in the same molecule, and you can close a ring with that. So we use grubs. Which grubs? Doesn't matter. We'll pick 2. All right. So we can count from inside carbon to inside carbon. 1, 2, 3, 4, 5, 6. So I make a 6-membered ring. So now I'm getting rid of my double bond. Right? So from E to F, I get rid of my double bond. So how do I get rid of a double bond? Every time someone on Zoom gets something right, they give themselves like a gummy bear. It's like, oh. It is. H2 palladium on carbon. Give yourself a gummy bear. Again, like I can't just like mail bags of gummy bears to everyone. It'd be weird. If you just got a box from Amazon and just had a card in it for a class next week, you'd be like, weird. Especially if they were the sugar-free gummy bears. No, it's not good. Why did he order me a big bag of sugar-free Haribo gummy bears? Do I have to post this on YouTube now? No. All right. So the thing that tricks people is, right, it is fine with me if you add this whole great big piece to your alkyne, right? Because that's the only way you know how to like build things is to deprotonate your alkyne and then add that carbon chain, right? Or that's one of the ways you know how to build things, the most common. So, right, people will be like, well, I didn't know I could add that many carbons. And if I give you that as an option, or that's the only thing you can do, you can add that many carbons, right? So like for A, we're going to do the 2 steps where we're going to add, I'll pick iodide, so I don't look all self-centered, right? We can 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So we did that right. So then what base do I have to use to deprotonate my alkyne, to make my acetylide? LDA, yes. And that'll give us our alkyne. I'm going to draw it the same-ish way. I guess I can't now. Right. Right, we can count one. There's a lot of numbers on this one. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I have the right number of carbons in both. Right? How can I go from an alkyne to an alkene? We've literally done this twice today. You know this, I swear. I was here for it and everything. Unless there really is drugs in these candy bars, and then I've hallucinated this whole like 45 minutes. That'll work. NH3 will work. You could use Lindlar's catalyst in H2, also okay. Right, because we don't care. It's a terminal alkene, so there's no cis trans to it, right? So it doesn't matter if we make this, if we're going to try to make the cis or the trans, that doesn't show up. We just care that we get a double bond out of it. BR, how many? 2. BR2, yes. D is 1 equivalent BR2. We turn this into a drinking game, but I think like participation would go down precipitously. Get like 3 right, you do a shot every time you get 1 right, and then like class just like devolves into chaos. Candy seems way better for focus. Right? Right, so 1 equivalent of BR2 gives you enough BR2 to react with one of the alkene pi bonds, but not both. So you have a double bond left over. Right, so now I have to build up my my alkene and get more carbons. So how would I do that? Let's say that you decided that this was B. Everyone's so shy. How many carbons am I adding from what I've got drawn for B to the given compound? From B to here is how many carbons? 2. So that means I have to add ethyl and then a halide. And then how do I do that? What do I need to add first? LD. What if we're out of LDA? N-butyllithium. Good job. You get a Mr. Goodbar. Oh. You get to pick one out of the floor after class. Okay, that one hit your hands like that. That wasn't my fault. That was good. That was good. I feel bad for this side of the room. So here. And Sydney's way far back. Here we go. Oh. She knocked it into her lap. It's fine. It's fine. She knocked it into her bag. It's fine. Okay. So then I've got to add how many carbons from the given thing to B? Said it once before. 4. Right? So we can use like NaNH2. And then sorry, that would be N-butyllithium. Sorry if my handwriting's trash. I don't know if that makes it any better. But N-butyllithium. NBU for N-butyl. And then Li lithium. So the thing that you need, I think the thing that helps the most with all of this stuff is knowing your reactions. So you can look at a product and go like, I know how to make that. Right? I know what reagent I have to use. And then I know what starting material that reagent has to react with, and that like lets you always fill in like 2 blanks before it, right? The last thing that I haven't had a chance to do, we'll do it real quick. So there's another way that you know how to add carbons to make a chain longer that doesn't require an alkyne, right? If you have an alkene, you can do olefin metathesis and add another alkene to it, right? So if you recognize that this right here, right, is kind of this part here, right? So you have to add this to your molecule, right? So I've got to go 1, 2, 3, and then I have to have a double bond. So 1, 2, 3, 1, 2, 3, and then I have to have a double bond. Oops, it's really ugly double bond, and then like grubs 2, right? So I can go 1, 2, 3, 1, 2, 3, right? And now how could I get a bromine on that carbon? You can just stop at HBr. So you're going to get a mixture of products because, right, what you're hoping to have happen is have the hydrogen add to this side, make that secondary carbocation, and then have that carbocation rearrange. Oops. To the tertiary, and then have Br minus add to that. Right? Half the time, you're going to put the hydrogen on the right carbon that you need to have this happen, and the other half the time, it's going to go on the other carbon, and you're going to make another product. If I give you something that, like, you could get 2 products, as long as the, like, reaction that you give me gets you one of those 2 products, I'm fine. So, know your reactions. Never forget anything ever. Stay inside and watch like Hocus Pocus, and don't go out and get the Rona. And I will see you guys on Monday.